Hello everyone, this is Zhengding. I'm a PhD student of Nanyang Technological University in Singapore. My paper accepted by ICASSP this year is Deep Generative Fixed Filter Active Noisy Control, abbreviated as GFANC. I will introduce my paper from 4 aspects. The first part is its background. It is also my motivation for this work. Adaptive ANC algorithms such as FXLMS depend on error signal to achieve adaptive updating of its control filter, which is limited by slow convergence speed and the possibility of divergence. To overcome the limitations, many ANC products will prefer fixed filter methods. However, traditional fixed filter methods only use a pre-trained control filter to do the noisy control. This method is only suitable for a specific noise type. When dealing with other types of noise, the performance will be degraded significantly. Therefore, Dr. Shi Dongyuan has proposed the selective fixed filter active noisy control method. We can call it SFANC. SFANC can select the best pre-trained control filters given different input noises. It doesn't require the error signal to update its control filter. It mainly uses CNN to do the control filter selection. The method has shown its advantage in terms of response speed and robustness. However, in SFANC, its control filters are shown in the picture. We can see the number of the pre-trained control filters is limited, resulting in poor noise reduction performance for some noise, especially when some noise are quite different from the filter training noise. Thus, we propose the GFANC method. In GFANC, different control filters can be generated by adaptively combining sub-control filters, which can provide a large amount of control filters to attenuate different primary noises. In GFANC, only one pre-trained control filter is required as a prior data, significantly reducing the effort for pre-training control filters. Then I will introduce the GFANC in detail. It shows its block diagram. In the diagram, we can see GFANC mainly include 2 parts. The one module is coprocessor. In coprocessor, we use 1D CNN to obtain the binary weights given the input noise. With the binary weights, we can do the weighted sum of sub-control filters to generate new control filters. The generated new control filters are used for real-time noisy control in the real-time controller. So the other module is the real-time controller. With the cooperation of real-time controller and the coprocessor, we can achieve delayless noise control. Because in coprocessor, it is processed by frame rate. However, in the real-time controller, it is processed by sampling rate. Before we do the GFANC method, we must obtain sub-control filters. We use the filter decomposition based on FFT to decompose a broadband pre-trained control filter into multiple sub-control filters. These sub-control filters will be used to generate different new control filters. Before we using the 1D CNN, we need to train the network. So we propose an adaptive labeling mechanism to automatically label the noises used for training network. This mechanism can greatly reduce the required human effort for labeling the noise. After training, the 1D CNN can output the binary weight vector dependent on the primary noise. Then a new control filter can be generated by the weighted sum of sub-control filters. Subsequently, the generated control filter is used to do the real-time noise cancellation. Next, I will show you some experimental results. Firstly, we compare some different networks in the GFANC, including some 1D CNNs and 2D CNNs. Compared with other works, our proposed 1D CNN network achieves the highest testing accuracy with fewer parameters. We also do some real-world noise cancellation. The first simulation is on aircraft noise. It is a dynamic noise, so it is a challenging work for some ANC to control the dynamic noise. Yeah. Compared with SFANC and FXLMS, our GFANC algorithm performs the best on the aircraft noise. Compared with SFANC, we can see the GFANC algorithm achieve higher noise reduction level. Also, compared with the adaptive algorithms, GFANC responds much faster on the noise. The next simulation is on a traffic noise. It is a broadband no-frequency noise. On the traffic noise, GFANC and SFANC can respond very quickly on the noise. However, the adaptive algorithms need some time to work on the noise because it needs some time to achieve convergence. Yeah. Finally, there are some conclusions. Based on deep learning and a perfect reconstruction filter bank, it means the subcontrol filters. Our GFANC method only requires operating the broadband control filter to automatically generate different control filters for various noises. Also, the training dataset is automatically labeled via an adaptive mechanism instead of human labeling. Finally, the simulation results indicate that the GFANC can achieve superior noise reduction performance than SFANC and achieve a faster response time than FXLMS when dealing with real-world noise. Thanks for your listening. If you are interested in my paper, we can discuss in Greece or discuss using email. Thanks for your listening.